Hey there, squad. This is time for a mean and terrible math teacher thing. Today I want to teach you how to compare slopes in different representations of relations. This is the kind of question math teachers love to ask, and they're not so simple. So if you would, please make this the title on the next free page in your math notebook, and when you have done that, close it up, brain on to 10 to try to figure this out. So we've been looking at relations for a few days. Sometimes we graph relations. Sometimes we just get ordered pairs that we can turn into a graph, and we can turn a graph into ordered pairs. Sometimes we get an equation that we could turn into ordered pairs, that we could turn into a graph if we wanted. Sometimes we get a verbal representation that we can turn into ordered pairs, that we could turn into a graph if we wanted. We've looked at all four quite a bit. And we've also been talking about slope, which is either the amount y changes when x increases by 1. So in this case here, with x increases by 1, y increases by 2. So the slope would be 2. Or it's the y to x ratio between easy ordered pairs. So like for instance here, my first strategy, x doesn't increase by 1. It increases by 2. So that first strategy is a little bit of a nuisance there. So what I can do instead is just pick any two ordered pairs on the graph or on the table, it doesn't matter which, say maybe that one and that one, and check the ratio of how they change. So in this case, y to x, y changes by from 11 up to 27, that's 16. When x changed by 2 up to 6, that's 4. 16 divided by 4 is 4. So that would have a slope of 4. So those are our two strategies for finding slope. And what happens today is we combine this. We combine slope and knowing 4 different ways to deal with relations into questions like this. The graph shows the cost to play games at store A. That's one way to represent a relation. The store B, the cost of games can be calculated by this relation. That's another way to show a relation. Which relation has the lower slope, aka which store charges less per game? Okay, this has a lower slope, or this has a lower slope. That's what we're talking about. These relations are in different representations, and we're still asked to compare them, which is greater, which is less. So what I like to do is to kind of set myself up on this because I want to compare them, so it'd be nice to have my sort of things laid out. So here's store A, I got the graph. Here's store B, I got the equation. And I'm going to find out which has the greater slope. So from the graph, I can find the slope pretty easy. I don't have to do a lot of changing on that one. So let's just, may as well start with what I can already do. I'll go easy ordered pairs. I'll pick this one and this one. So let's see, from there to there and from there to there. Either slope strategy is fine. In this case, the games increase by from 1 to 4, that's 3. Cost increases from 10 to 25, that is 15. So my y to x change ratio is 15 to 3, that is 5. So that has a slope of 5, it would appear. If I use the other strategy, that's what I would get. If x increases by 1, y increases by 5. 5 again, either way. So what's the slope here? I don't know. We didn't learn how to find slope from this. We only learned how to find slope from this and from this. So if I'm going to find slope, I need to turn this into either this or this. And that's the one we learned how to do. We did learn how to get ordered pairs from an equation. So in this case, I don't have x and y, I have g and c. Let me erase and rewrite that. G and c. And how did we get ordered pairs from this to this? Well, we just kind of made up numbers for g. What if g is 0? What if g is 1? What if g is 2? What if g is 3? I just pick easy ones. Doesn't have to be. And then we figure out our c. So I'm going to come down here. What if g is 0? If g is 0, then c is 4 times 0 is 0. plus 10 is 10. What if G is 1? Then sorry, phone's ringing. So if G is 1, then 4 times 1 is 4, plus 10 is 14. If G is 2, 4 times 2 is 8, plus 10 is 18. And if G is 3, 4 times 3 is 12, plus 10 is 22. So either slope strategy is now available to me from here. Once I have the ordered pairs, I can use either slope strategy I want, and I'm going to know if store B or store A has a lower slope, which would be a cheaper price per game. The easiest one here looks to be when X changes by 1, Y changes by 4. Changes by 1, changes by 4. Changes by 1, changes by 4, so my slope is 4. So store B, if that slope is here, it's the same down here. So store B has a slope of 4. Store A has a slope of 5. So that means store B charges $1 less $1 per game. And that's how it works. Open your math notebook. Let's do one together. Loganville and Grayson are both having fairs the same weekend. Here are their ticket prices. Which relation has a lower slope, aka which fair charges less per ticket? Well, two different representations of slope. I've got to find it from each. So what I like to do, I don't like to do it when I do this because I don't need to change anything. Sorry about that. I can find the slope here, and I can find the slope here, and I can compare them. These are the two formats where I know my slope the easiest. Verbal representation takes some work. Equation takes some work. But here, I'm just asked to find it from these two things. So let's do. So here, let's think of my slope strategies. When X changes by 1, how much does Y change by? Well, X doesn't change by 1. Changes by 2, so let's not use that one. Let's use the easy ordered pair strategy. They're all easy ordered pairs. Take your pick. Maybe use the first two. Find your Y to X ratio. So in this case, when Y changes by 3, X changes by 2. 3 divided by 2, or 3/2, that's 1.5 or 1.5 slope. So that is the Loganville slope. What about the Grayson Fair slope? Well, looks like either strategy is available to me here. I think I could do the X changes by 1, Y changes by what? Or I could pick easy ordered pairs. They're available to me as well. Since the graph's so small, I may do easy ordered pairs. That my little triangle there is going to be awfully little. I'll pick maybe those outer two ordered pairs there and there and find my Y to X ratio. So in this case, my X changes from 2 to 8. That is 6. Is that right? I did that right. My Y changes from 24 to, what's this even going by? Ugh, these are 8 apart, so I guess in between would be 4. So that goes from 24 to 30. Each one of these is 4, I said, right? 4, 8, 12. So it looks like 12. So that's a slope of 2. So remember, slope and unit rate are the same thing. So this is $1.50 per ticket. This is $2 per ticket. I think you're better off going to Loganville. Cheaper, lower slope. So that's, y'all, how you compare slopes when your relations are in different formats. Hope it made a lot of sense. If it did, you're all set. If not, give it another watch. Come to school confident and ready to roll tomorrow so that you feel good and feel like you're on top of things. Can't wait. See you then.